Hello everyone, and welcome to this lesson. Today we'll be exploring the exciting world of large language model applications by leveraging OpenAI Python library. We'll dive into the process of setting up and configuring these models in Python and touch up on some vital considerations such as selecting the right GPT model for your specific needs and understanding the effects of tuning various parameters. One aspect of working with the OpenAI API that can pose a challenge is the stateless nature of the models. This means that they don't automatically retain information about previous interactions or messages. Consequently, a custom solution is required to maintain conversation memory. But don't worry, I'll guide you through a simple method for handling this issue. By the end of this lesson, you'll be armed with the knowledge to create your own ChatGPT clone right from your Python console. And to add a touch of creativity, I'll also demonstrate how you can customize the personality in your chatbot. So first, let's discuss what are the pros and cons of using the OpenAI Python library versus the Langchain framework. Well, Langchain is built on top of the OpenAI library. And from my experience, there are less abstractions with OpenAI and it's easier to understand. Though it is less powerful than Langchain, such as there's no out-of-the-box solutions for very popular techniques like retrieval question and answering and agents. But for many simple LLM projects, OpenAI Python library is perfectly viable. Langchain is very popular amongst LLM developers. There's lots of features that are abstracted, so this makes it hard to understand. However, overall, it's great for streamlining larger, more complex LLM applications. So I provided links below so you could check out their native documentation. Okay. So the first step is starting your OpenAI account and obtaining the API key. So we go to platform.openai.com. I already have an account, but if you don't, you have to register. Click on the top right, go to view API keys. As you can see, I've been doing this for a while, so I already have a few API keys in the works. If you want to create a new one, just click here. Lesson key, give it a name. Make sure you copy the API key on your clipboard. And there you have it. So here's a demonstration of the code on Google Colab. Right, first thing you do is install OpenAI. And run this. This is just to wrap text in the Google Colab cells. All right. And then I'm going to demonstrate very quickly how you use it. Right. You enter your API key here. Okay. On that. And then what this does is just stores the API key inside the OpenAI object, right? So if you want to see if that persists, just play this. Yeah, so this is the same as what I entered. Okay, so here's an example of how it works. To use a model, you call upon the ChatCompletion method in the OpenAI object. So if whatever you want to ask, you would put it in this message format. Try that. And this is the format of the response. It has some useful information such as the timestamp that's created in, the amount of tokens that it used. But most of the time, you just want the message content, right? So this is how you parse that out. And there you go. You have the answer to the question. The alternative method to using the API is not to import the OpenAI Python library at all, right? So you can just access ChatGPT functions through HTTP request. So this is how you do it. First, specify the correct URL, right? You would format the parameters such as the model and the prompt in this format and payload. And then you enter your API key in headers. Then just make the HTTP request with this function and you get a response. and this is what the response look like. So it returns a HTTP status code. If you're not familiar with that, that's okay. You don't really need to know. All you need to be concerned with is that 200, it means successful response. Okay, and if you want to parse the message out, you have to use Python's JSON library. Just play this, and there you go. As we delve into working with OpenAI's GPT models, it's important to understand the parameters that govern their behavior. On this slide, you'll see an overview of these parameters and description of how they can impact the output of GPT models. First argument is usually the specific model you want to use. Choosing the right models such as GPT-3 or GPT-4 for your specific app can have a significant impact on results. Factors such as complexity of capabilities, costs are considered when choosing the model for your app. Next is the temperature setting. This sets the randomness of the model's output. Higher value makes the response more creative and diverse, while lower value results in more deterministic outputs. The top P parameter is an alternative to the temperature setting. A simple explanation is that it controls the diversity of the predicted response. So setting it to 0.1 means the model will draw from the top 10% of all most likely token outputs. Next, we have max tokens parameter. This sets the maximum length of the output. This can be a good way to limit the model's response so that you preserve token usage, or if you want to ensure a concise response. There are, of course, other parameters to set. I've only covered a few here. I highly recommend you check out the original documentation to get used to all the other parameters in the OpenAI models. Two model parameters I want to focus in this lesson is the temperature and the top P. I found this chart online and I thought it did a really good job of summarizing how to use temperature and top P to tune the output, and in what cases would you want high creative outputs versus low temperature predictive outputs. So check it out. One crucial decision you'll face when building your application is choosing the right model for your specific needs. The table I made summarizes most commonly used GPT family of models. There are a few key distinctions in each model, and you can tell them apart by just the naming. First big distinction is between the base models, GPT-4 and GPT 3.5. I won't go into too much details about how they're created and the training methods. All you need to know is that GPT-4 performs better, though GPT 3.5 is faster and 20 times cheaper. In both base models, you'll see this -0613 flag. And all that means is that the models are frozen at the date of June 13th, 2023. But they have this advanced feature called function calling. You don't need to be concerned about that in this lesson, but in the future, if you want to do like really cool things with these models, look up that. From my experience, most of the time, GPT 3.5 works fine, and it is by far the cheapest model. So I recommend using that as a default. When you encounter a few special cases where you may need a larger token limit, or you want better performance on a more complex inference task, then consider the alternatives in this table. Last thing I want to mention is that you might see this other model called TextDaVinci 003. I don't recommend using that. It's an older model that is essentially being replaced by GPT 3.5 Turbo. For those who have used it, you notice that it costs 10 times more than GPT 3.5, but has nearly identical performance. And here I just want to show the OpenAI Playground. This is just a web page where it allows you to play around with the parameters I just talked about. And yeah, just test different prompts and test the outputs. So I highly recommend you check that out as you're building your LLM applications. Okay, so let's continue with the code. Here I wrote a wrapper function, ChatCompletion, around the original ChatCompletion function. And the reason for doing this is so that I could set my own default parameters, and allows me to just filter out the message content that I want. So let's play that. So there you go. So instead of writing this code and parsing the output every time you just want the answer, you can just call upon your chat completion wrapper function. Next, I want to just run a little experiment with tuning temperature and top P parameters. So here's a very simple prompt, right? What is 123 times 69,420 equal to? And this is the correct answer, right? Now let's run this 3 times with the highest temperature and highest top P setting and see what we get. Okay, yeah. Again, first response is wildly incorrect. Second response is closer, but still incorrect. Third response, close, but still not correct. Okay, and here I'm going to try it with very low temperature and very low top P. So as you can see, every time I run chat completion, the response is identical, right? So low temperature, low top P yields a very deterministic response. Even though the answer is still not correct, the response is consistent. As I mentioned before, the model is stateless. It doesn't automatically remember what you said before. If you want each response to remember the context of the conversation, then you would have to enter the previous messages manually into the function. This slide illustrates the format in which the messages should be structured. As you can see, you'll need to create an array of message objects, each containing a role, content property, and the role can be either system, user, or assistant. And the content will just contain the actual text of the message. The system role typically includes instructions that steers the behavior of the model. Some examples of behaviors I've seen developers use are custom personalities or personas, or using the system prompt for focusing the conversation. For example, imagine you're building a chatbot for taking pizza orders, and you want the bot to only respond to pizza ordering related questions. The user role represents the input from the user or the question being asked, and the assistant role just contains the model's response to the user. By structuring your messages in this way, you can create a continuous conversation where each response takes into account the entire context. It's an effective way to make the conversation feel more natural and coherent. Let's go back to code. So here's an example of how you would handle conversations. Let's try this. And there you go. But as you can imagine, entering each message in the message history manually, doing in this way is quite tedious. So the best way, I guess, to keep conversation is to implement a class structure, right? So let's create the conversation class. First, we initialize the attributes, which most of it is just the same parameters for the chat completion function. The system message will go as the first message in the chat history attribute. We want to create a method to add more messages to this chat history. Then last method is just to get the response from the chat completion function. But in addition, we may want to store certain pieces of information, such as the finish reason or the token usage. So here, I'll create 2 new attributes, token lock and finish reason, and I'll update them after every call of chat completion. And there you have it. So let's try out this conversation class, conversation object. Here I instantiate the conversation to chat session. I want to ask it to tell me a joke and then get a response using the chat method. Let's see if this works. There you go, works. All right, and you can see that The finish reason and token log attribute is updated. Now let's prompt it again. What was the first joke in the conversation? Let's see if it remembers. Let's add one more method, the run method. And all this does is create a continuous loop for you to input your questions or prompts. Okay? So if you do this again, this time set max tokens to 200. There should be an input box. It's not working. Oh, there we go. There. Okay, so hello. Who is Keanu Reeves? What are his most famous movies? There you go. So now we have a running chatbot inside our Python console, and it can keep track of conversation. Interestingly, we see that the response was cut short because the token limit was reached, right? And when token limit's reached, you can see that token log, has reached the limit of 200, which we preset here. Okay, next I want to show you how you can give your chatbot personality. So here's a prompt I made, and it's just telling the chatbot to impersonate this cartoon character called Rick Sanchez from the popular Rick and Morty animation. So here you could take a look at it, and it, it's accentuating certain personality of the character. I'm gonna run this. Okay, so let's do rickbot.run. Hopefully it works. No. Again, you gotta do this a few times. There we go. So let's play with it. Well, well, if it isn't Morty, my loyal sidekick. What do you want now, Morty? Can you see I'm busy with important interdimensional experiments here? Who are you? That's pretty funny. Okay, so I'd say that worked. That was a success. So that is the end of the lesson. I hope you find this video helpful. If you have any questions about this code or anything I discussed in this video, feel free to message me. I encourage you to copy my code and try some of these exercises I made up. In the next lesson, I'll teach the basics of Langchain and try to repeat everything I did in the Langchain framework. So stay tuned. And thanks for watching.